So we have slowly inched up and we are at the topmost layer, application layer. At this layer, we can only look at protocol specific attacks. So we will look at some of these attacks and solutions to the same. So if you look at the layers below the application, that is the transport, network and link and physical, all these have put in place a mechanism whereby you can transfer packets from one process on a given host to another process on another host. So this is the networking infrastructure that is in place. Now you can make use of this networking infrastructure to enable variety of applications at the application layer. So what do these application developers do? They essentially build these interesting useful applications like for example the web or email or FTP and so on. And while they build this, they have to understand the building blocks that are underneath it and how they interact so that they can design efficient applications. So in designing this, they'll make the right choices and implement the required functionality. There are very many applications, as you all know. We will cover only those that are highlighted in red as part of security. So email and web I will cover later because these are slightly bigger topics. In this video, I will focus on domain name system, DNS, which is a core functionality of the internet, but which is implemented at the application layer. So what does DNS do? So DNS does many things. It does mail server aliasing, load balancing and so on. But I think what you're most familiar with is illustrated by this example. So when a user types on his web browser a specific URL like http://www.facebook.com, he is essentially saying, I want to talk with this particular web server. So before you assemble a packet and send it out to the web server, you need to know what the IP address of this host is, because that is what the network layer will expect. So for that, you rely on the DNS service. So you ask the DNS service, this is the host name, what is its IP address, and DNS service will give this particular IP address. Based on this, you pass the information down and finally some network layer packet will get assembled where source is the user's IP address and the destination will be this 31.13. address. So why like this? Because people like us, we can easily remember Facebook, Google, so on, prefer host names, whereas routers prefer IP addresses and we as humans cannot remember these IP addresses. So we need a service that converts these host names to values. As I mentioned, DNS also converts domains to values. It can also do aliasing where it can convert host names to other host names as well. You should know all that by now. So how is DNS implemented? It follows a hierarchical and distributed architecture as shown in this figure. So at the very top, there are something called root DNS servers. There are about 13 of them. And the next level of hierarchy are top level domain servers. Some of these you may have heard of: com, org, edu, net, mil for military, gov for government, in for India, fr for France. So these are country level domains. So what this means is if you contact the root DNS server, this will definitely know the IP address of the com domain server, or IP address of the org domain server, IP address of the in domain server. And each of this com will in turn know the IP address of the domain server that is managing the Amazon company, that is managing Facebook. Similarly, org will know the DNS servers of Wikipedia and ACM and so on. So if you see here in, that is where we are. So this in will know the IP address of the AC DNS server. AC in turn will know the IP address of the IITB's DNS server, and IITB in turn will know the DNS server that serves CSC. So this is the structure in which things are organized. Apart from these DNS servers, there is also something called a local DNS server that provides services to hosts within an organization. I will give a concrete example that tells how all of these interact. That will make things clear. So let us look at it. So here is that example. So this is your machine and you want to access, like in the previous example, Facebook's web server, for which you need to know its IP address. So your machine is part of some organization, let's say it is part of IITB, and thereby you will invoke the services of IITB's local DNS server. So there will be something called local DNS server, which is your local DNS server. When you do this DHCP, you can potentially get hold of who is your local DNS server so that you can contact it. So you will contact, so you can assume that every host knows the IP address of its local DNS server. This it gets through some means. And you are going to contact this local DNS server and ask it what is the IP address of facebook.com. Now it is the responsibility of this local DNS server to somehow figure out this information and pass it back to you. Now how does this local DNS manage it? So let's say it does not have anything cached. So the first thing it will do is it is going to contact the root DNS server and ask it, can you tell me what is the IP address of facebook.com? Now the root DNS server knows only information about the top level domain. So it is going to process this host name from right to left. So it is going to look at com and say, okay, fine. I don't know what the exact IP address of this host name is. Why don't you try contacting .com domain server, and this is its IP address. So you get that particular information. Then you're going to contact this com top level domain server and ask it, can you tell me what is the IP address of this? So this guy also may not know the exact IP address of this host, but it knows, because it is managing all the com companies, it knows what the DNS server of Facebook is. So it will say, I don't know what the IP address of this entire host is, but why don't you try contacting a.ns.facebook.com, which is serving the Facebook company. It will be able to help you, and it will also tell you what the IP address of this is. So then you will contact the Facebook's authoritative server, which is this IP address, and this should definitely know all the host names that are part of the Facebook's company. So it will know the web server of Facebook, the IP address corresponding to it. Thereby it will say this is the answer. And once you get the answer, you pass it back to the user. So this is how the DNS operates. So two other things you should be aware of in this context is that this DNS server, once it gets this answer, it can cache this entry so that later if some other user were to ask this same question, it already has the answer in the cache and it will pass this information back. And this cache, like anything else, has an expiry date. In other words, entries are not cached indefinitely. They are discarded after some time. How long to keep this entry? Actually, this server, which is the authoritative server, as part of the answer here, it will tell. So here are some more details. All these DNS servers, be it top level, authoritative, root, they store something called resource records. RRs, these are called. This resource record is made up of 4 values: name, value, type, and time to live. As I mentioned, this is the expiry date associated with this record. Now, depending upon what the type is, this relation between name and value will change. For example, if the type is A, that means the name will be a host name and value will be an IP address. So for example, this. So what this is telling is, this is a type A record, which is saying this host name maps to this particular IP address. The type can be NS, in which case the name is a domain and the value is the authoritative name server that is serving that particular domain. What this means is, you have facebook.com, this is a domain. don't confuse www.facebook.com, because www.facebook.com is a host name. It is not a domain. It is some machine within that particular domain, which is typically the web server. Now, facebook.com is a domain, and there is an authoritative name server that is serving that domain. In other words, that authoritative name server, which is this, knows the IP addresses of all the hosts that are part of this domain. So you typically contact this to get the individual IP addresses, as we have seen earlier. And this record essentially is an NS record that says this domain is being served by this authoritative name server. There is also a type CNAME record. This is mainly for aliasing. So what this tells is www.facebook.com is what the outside world knows, but this internally actually maps to a machine whose host name is this. And this is a canonical name because this is basically for aliasing. MX record is for mail server. So again, this says this domain. Sorry, this is not host name, this is domain. So what this entry means is that this domain is being served by this mail server. So this is used in email applications. Even email applications make use of DNS servers to figure out which mail server to contact to pass on the emails. Okay, a few more details. So before I dig in, let's talk about what an authoritative name server and a non-authoritative name server is. This is all relative to a given host. So let's talk about from the perspective of the example we have seen. Let's say there is a host name called facebook.com. This is nothing but the web server of Facebook. Now this host has an authoritative server. Authoritative means this server will definitely know what is the IP address of this particular host name. And this host will also have a non-authoritative name server. In other words, any DNS server that does not know its IP address will be a non-authoritative name server. Now, what these rules are saying is that an authoritative name server should always contain a type A record of that particular host. That is what authoritative actually means. That is the definition of authoritative. So this is a given. This non-authoritative name server, for example, for this host, the non-authoritative name server could be the .com TLD server, or it could even be the root TLD server, because both don't know what is the IP address of this. So let's focus on the .com TLD server. What entry should this contain? This should definitely contain an NS record for that particular domain. In other words, it should contain this entry, which is essentially telling this domain, this is the authoritative name server. Note that this is actually host name of the authoritative DNS server. It should also contain a type A record of this authoritative server. That is, it should also map what this host name maps to in the IP address. Why like this? It is because of the following reason. Suppose you are resolving this host name and root asked you to contact .com TLD. So you had contacted the .com TLD. Now if this .com TLD as an answer gave back only the first record, it is saying fine, I don't know, but this is being served by this authoritative name server. Why don't you ask this authoritative name server what the IP address is? It will surely know. Now for you to contact this authoritative name server of the Facebook domain, you need the IP address of this, for which again you have to use the DNS server service. Then you will ask another question saying what is the IP address of a.ns.facebook.com. You may go to the root will say contact.com, and then you are going to contact.com, and then it should have this entry, because if it didn't have this entry, then you cannot proceed further, for which it has to have a type A entry. That is what this is telling. So dig is a command that you can use to do these type of name resolutions yourself. You may want to check it out. There is also a video that does a demo of this. I will upload it. If you're interested, you can go through this. So here is the DNS message format. Remember that DNS is an application layer protocol that runs over UDP and it uses the port 53. So this is what DNS is generating, and it will pass it down the protocol stack. Then you add a transport layer header, network layer header, and so on. So what are the fields that are part of this DNS message? So first is a identification field. This is a very important field which we will look at later as well. So the reason for identification is, as part of the DNS, you are going to send out a request asking some question and you're going to get a reply. Now this reply has to be mapped to this request because you may be sending out many requests. That is why you use an identification field. For example, if this is set to 750 and you got a reply 750, you know this reply matches this request. Flags are that tells whether it is a query, whether it is a reply, and so on. You may be asking many questions within this DNS. So how many questions you are asking? And in the reply, how many answers are you providing? So these both, so in other words, the same message format is used both for request as well as reply. That is why you have these different fields. I won't get into many other details. So here are all the questions that you are asking. This will be as part of the request. The answers that are being provided will be part of the replies. And this is again something important which we are going to see again. You also often provide additional information in the form of glue records. Like in the example that I covered earlier, when you contact the .com TLD, top level domain server, this is telling the following. Basically, it is telling that this is the name server of a.ns.facebook.com. That is the answer to your query, because it doesn't know what the IP address is. It is saying, I don't know, contact this guy, he will know. So that is the proper answer for that query. But in order for you to proceed further, I also mentioned that you have to send this field as well. So in this example that I covered here, I'm doing this via two messages. There is really no reasons why you have to do two messages. You know that invariably it is going to ask what is the IP address of this. So you might as well send this information along with the previous message. And this is what is called a glue record. So this information that you are sending is also sent here as part of additional information, because this is something that local DNS server will anyway require for proceeding further. So these are helpful records that you send along with the answer. So that is the background with respect to DNS. This is again a high level overview. If you don't understand some things, you have to dig in further. This you have to do it on your own, because this is not a networks course, this is a security course. So now that you understood the DNS, so what are the vulnerabilities with this protocol? There are two vulnerabilities.